and welcome yet again to the eLearn program brought to you by the Division of Education, Innovation and Energy. My name is Mr. Shea Thomas, and I'll be continuing on a part of organic chemistry. We would have started this part, and I pray that through this lesson that you will learn and it would be helpful for you in the long run. All right, so let's do a little practice. Name the following alcohols. So we're going to name this alcohol. As you can see, there are condensed formulas. It's in a condensed formula. I did this on purpose so that you will have the practice. For those who do not remember, anytime we have the condensed formula, what does it mean? So we see a CH3 group here. It means, therefore, it's carbon bonded to 3 hydrogens. And we have how many carbons? We have 1, 2, 3, 4, 5. All right, so there are 5 carbons. So we know that these 5 carbons are laid out 1, 2, 3, 4, and 5. All right, so the carbon that follows the carbon with the CH3 group contains 2 hydrogens. So we have 2 hydrogens. This is why we have, and there's 2 hydrogens next to that one, and 2 hydrogens next to the other one. And 2 hydrogens next to that of the other, which has the OH group. So the CH2 represents this one here. The second CH2 represents this one. The third represents this one. The fourth represents this one. And of course, the last one represents this one. Okay? So if ever you have any problems with your condensed formula, what is advised for you to do is basically probably just draw it out again in the fully structural formula, the fully displayed structural formula, and you can be able to be guided from there accordingly. All right, so let's name the compound. So we're going to get the name of that compound. So what is the name of this compound? There is how many carbons we have there? 5 carbons, and there's an OH group. All right, so there are 5 carbons. 1, 2, 3, 4, 5. We would have numbered them earlier. And we know from our rules that we are to number the carbons in the direction from the functional group. From the functional group. All right. So we're going to have carbon 1, 2, 3, 4, and 5. So the OH group is found on the first carbon. So I'm going to call this particular compound pent because there is only 5 carbons. So we're going to call it pentanol. And of course, the OH group is found on the first carbon. So we're going to call it 1-pentanol. Okay. So let me erase this here so we can have space for the others that is going to follow. So the name of this compound is called 1-pentanol, or we can call it pentan. 1-all. All right. So let's look at the second one. All right. So we're going to look at the second compound. So what's the first thing we need to do? We need to find out the longest chain. All right. So we've seen an OH group there. We see the OH group is out here. It's like a branch on the outside here. All right, so the OH group is like a branch on the outside here. So we need to look at the longest possible chain. So we're going to look at the longest chain. We know that this is going to be the longest chain. All right, so let's begin. We have to number the carbons that from the end that is closest to the OH group. So we have the OH group here. So this carbon is going to be the closest one. So we're going to call it 1, 2, 3, 4, and 5. So we have 5 carbons present. So since there are 5 carbons present, we know that we are dealing with pentan, and since it's an OH there, we call it pentanol. So we just simply need to find out where the OH group is found, and it's found on the second carbon. So we're going to put a 2, so we call it 2-pentanol. All right, so let's move on to the next one. All right, so we have another example here, and we see our OH group, which is here. So we identify OH group, and we know that when we are naming these compounds, we look at the carbon closest to the OH group. So we want to organize from there. So we're going to organize our longest chain, and our longest chain must include our OH group present inside of it. So we have our longest chain being here. So this is carbon number 1, carbon 2, 3, and 4. All right, so this here is going to be a branch. So we're going to call this 1. Let's name the longest chain. 1, 2, 3, 4. So since the longest chain has 4, we're going to call it butanol. We figure out, or we find out where number the OH group is on. It's on the first carbon. So we're going to put 1-butanol, and our group now, which is a CH3 group, we call them methyl. And since it's on the second carbon, we call it 2-methyl. So the name of this compound would be 2-methyl-1-butanol. All right? So let's look at this one. This is going to be our last example for this particular question. So you're just looking at some tough ones. All right. So let's look at this one here. Let's examine it. So we know our OH group is present here. All right. Next, we need to find the longest chain, and we need to find the longest chain. We need to begin with the carbon that is closest to the OH group. So this is the carbon closest to the OH group, and we're going to find our longest chain. 1, 2, 3. All right. So we have our longest chain being right here. So since it's 3, 1, 2, and 3. We found out that our OH group is found on the 1 carbon, so we know 3 carbons is referred to as propanol. And it being propanol, our OH group is found on the first carbon, and we have some groups here present. Because I know some of you students are going to ask, sir, what about if there are more than one of the same branches present? We're going to apply it as we would have learned in the video before this. All right. So when you have 2 methyl groups, so we have a methyl here, and we have a methyl group here. Anytime we have 2 of the same groups, we use di to represent them. All right. We used another prefix, di, tri, tetra, etc. And we will state what number carbons they are on. So they are both are on carbon 2. So we have to put 2, and we have to put the both numbers just as we would have learned the last time, that we must state where each of these groups are, each of these branches are, to ensure that we have the correct name. All right? And of course, to have no problems. And we want to make sure that we have this practice so that we could apply it in other areas that might probably come in the future, right? So the name of this compound is going to be 2,2-dimethyl-1-propanol. All right, so let's move on to the next area. So we're going to look at alkanoic acids. What is an alkanoic acid? All right, so an alkanoic acid or a carboxylic acid has a carboxyl group which is represented as COOH, as their functional group. So this is how it looks. All right, every time you see this particular group, which is a carbon double bonded to an oxygen, and that same carbon is bonded to an OH bond, an OH group, that is a carboxyl group. They have a general formula of CnH2n plus 1 COOH. We would have learned this before. And alkanoic acids are named by using the prefix indicating the number of carbon atoms in the molecule plus the ending anoic acid. So example, we have CH3COOH. There are 2 carbons present. So we know that it's going to be eth. Therefore, the name derived is going to be ethanoic acid. Okay? Now, where alkanoic acids are concerned, for this level of chemistry, you don't do isomers. So what we're going to do is just basically remember how to give you a little practice again, how to draw your alkanoic acids. All right? In addition to that, this is one of the areas that I said is the tricky one. You have to always remember your general formula, and always remember that your general formula has a carbon inside of it. So we are looking at drawing them. So we're going to look at drawing the methanoic acid. So we know that alkanoic acids has a functional group, which is a carbon double bonded to an. So you can place your functional group out. All right. So our first one, we have HCOOH. So we're going to name them and we're going to draw them. So it has 1 carbon in it. So we know that this is going to be called meth for 1 carbon. And we're going to add anoic acid. So it's methanoic acid for the first one. And of course, there's 1 carbon. This is 1 carbon, which is the functional group, and that's bonded to an H. So there's a quite interesting thing about methanoic acid. Methanoic acid is actually found in the stings of ants. So you know, sometimes when you get a little sting from an ant, how it burns that area and becomes irritated. Please know that what is being injected by the ant into the skin or the area that was bitten is actually methanoic acid. All right. There are other creatures that have similar compounds inside of them. This is just information, just a little bit of information on the next hand about methanoic acid. Anyways, let's continue drawing. So let's look at ethanoic acid. So we call ethanoic acid because there are 2 carbons, all right, present. So we know 2 is eth, so we call it ethanoic acid. So how we draw them? So we know that 1 carbon is going to be your functional group bonded to an OH group, and of course another carbon is going to be added to that. So EH, this carbon. So there are 3 hydrogens, 1, 2, 3. So these are the 3 hydrogens that we have here, and our carboxylic acid group. So let's look at the next one, C2H5, COOH. So there are 2 plus 1, there are 3 carbons present. So there are 3 carbons present, so we will call this propanoic acid. So being propanoic acid, how are we going to draw this particular one? Let's erase this area here. So propanoic acid is going to have 3 carbons, and one of them is going to have the functional group. All right? And of course, the rest is going to have hydrogens attached to it. This is how simple this particular drawing is. Very, very, very simple. And of course, that is your complete structure of propanoic acid. The next one will have 4. That's 3 plus 1. So we know that is buthanoic acid. All right, so I'm not going to draw it because we understand how simple these things are. It's going to be, of course, a chain that contains 4 carbon atoms, one of which contains the functional group, and the rest of the carbons is going to contain hydrogen. All right, so let's do some practice. All right, so as I said earlier, that where CXC is concerned, they don't go into isomers with alkanoic acids. So one of the key things that you will note for alkanoic acids is just basically understanding how to name them, and in addition to that, understanding the general formula when you're writing the formulas on them, that one of the carbons that is within the formula is part of the functional group. Always remember that. It's very, very important. All right, so let's look at some CXC type questions here now. So this question is asking, how many isomers of butane C4H10 are there? 1, A1, B2, C3, D4. How am I going to get this information? One, I need to draw my isomers out. Okay? So, how do we learn how to draw isomers of butane? So, we're going right back. So, there are 4 carbons present. And since it's called butane, having the ane at the end, we know that it's an alkane. All right, so we know that there are single bonds between the carbons, so I'm not going to alter anything there. So it's just single bonds, and they are bonded to hydrogens. So I'm not going to put in the hydrogens here now. We're just going to understand that the hydrogens are there present. All right, so this is the first isomer. All right, if you remember in drawing alkanes that you can't shift a functional group because the functional group is the entire thing basically. All right, so the first step in doing isomers for alkanes is by actually taking the branches. All right, so we're going to take a carbon from an end, and we're going to use it and make a branch. Okay, so I'm going to take one of the carbons on the ends, so that's going to leave me with 3 carbons, and I'm going to put it on the adjacent carbon. So I'm going to put it here, and this is connected to 3 hydrogens, and the rest would have hydrogens bonded to them, of course. All right. All right, so they're going to have hydrogens on this. So this is our next one. This is another isomer. So far we have 2. Can I draw another one? All right, let me see. I am seeing there's no way, because if I decide to shift or pull out another isomer, I'm going to be getting the same thing, because if I take this and I draw it here, I'm going to get back this particular compound. If I take this and I connect it to this carbon, I'm going to get the same long chain. So from my observation, I can only have 2 isomers being formed from C4H10. All right, 2 isomers. All right, let's look at another question. Which of the following structures represents a molecule of but2ene? So let's look at the structures. A, B, C, or V. So they said but2ene. So we know that we are dealing with an ene, which is an alkene. All right? And of course, it must have double bonds, and every single option that we have a double bond inside of it. In addition, that we have but. So if we have but, there must be 4 carbons present, and we know that this particular question has 3, so this one is out, and this one has 3, so this is out. But the 2 on the top, A and B, would have double bonds. I would have 4 carbons in them. So we look at the number 2, and remember what the number 2 tells us? It tells us where the double bond is located. If we look at the first one, where we number them 1, 2, this double bond is found on the first carbon. And whereas we look at the second one, 1, 2, the double bond begins on the second carbon. So B would be our answer. All right. Moving ahead. Next question. It says, to which homologous series does the following structure belong? This is the following structure, and I'm sure some of you all are belting out the answers right now. So 1, how do we know what homologous series a compound belongs to? We look at the functional group. So the functional group here is COOH. All right, we would have learned this, the alkanoic acid. And since we know that alkanoic acids are also called carboxylic acids, so D is your answer. All right, next question. Which of the following is the correct formula for pentanol? All right, so we have A, B, C, or D. So we are looking at pentanol. So we know it's an alcohol, as we see alcohol. And alcohol has OH groups. And all of these answers have OH groups. In addition, they are asking for pent, so they must have 5 carbons in it. All of them have 5 carbons in it. So what is the answer? By observing, we know we have to look for the general formula. We need to find the general formula based on this particular question. So what is the general formula for an alcohol? CnH2n. As we said, all of our general formulas begin with this particular area. And for alcohols, it's going to be +1 OH. So I know I have 5 carbons present, so I know it to be C5, and 2 times 5, 2 times n, is going to give you 10. 10 plus 1 is 11 OH. And I'm going to get my formula, and my answer would be B. Okay? So moving on from there. The fully displayed structural formula of 5 organic compounds are given. So we're going to look at a little bit of a more structured question. All right, so of 5 compounds, 1, 2, 3, 4, and 5. First question says, which compounds belong to the same homologous series? So there's 1 mark there. So they're asking which compounds belong to the same homologous series. So how would we know that? We need to look at our functional groups. So if we look at A has an OH, B has a double bond, C has an OH. So we found out one time having an OH group present, and we know this has an OH, but it's a C double bond O, so that does not belong to the same group, and this does not have an OH. So the compounds that belong in the same homologous series are A and C. All right, moving on from there. Name the homologous series to which the compounds you named in I belong, and give a reason for placing them in the same series. So 1, what is your reasoning for this? All right, so they're asking, give the name of the homologous series, to which they belong, and what's your reasoning? All right, so 1, the reason for putting them in the same homologous series would be because they both have the same functional group. So the functional group they belong to is alcohols, right? All right. What's your reasoning? The reasoning is because they both have a hydroxyl functional group. All right, and that's your reasoning right there. So 2 marks in the bag. All right, so let's go ahead. Next question, 3 says, give the names of the compounds B and D. So what are the names of the compound B and D? So B, as we note, has a double bond. So we know that it belongs to alkenes. So we know the end is going to be an ene. All right. In addition to that, we see that there are how many carbons? 1, 2, 3, 4. And please note where I begin my numbers. I began numbering at the carbon that is closest to the functional group. So I know that there are 4 carbons, so I know that it's going to be butene. But the number that the first carbon is on is 1, so the name of that one is called 1-butene. So let's look at D now. So D, as we can see, the functional group is a COOH, all right, or a carboxylic acid functional group. So, or carboxyl functional groups, and there are 2 carbons, all right. And since there are 2 carbons and it's a carboxylic acid, I know that my end is anoic acid. And there are 2 carbons, and the symbol for 2 is eth. So it's going to be ethanoic acid. All right, so we finish with those 2. That's 2 marks in the bag. Moving on again. So give the name and the fully displayed structural formula of the compounds which has 4 carbon atoms in its molecule and belongs to the same homologous series as compound D. All right, so compound D. So the question they're asking to give the name and the fully displayed structural formula, all right, of a compound that has 4 carbons and belong to the same homologous series. So if it has 4 carbons and it belongs to the same homologous series as D, therefore we know that it's going to have an ending which is anoic acid. And lastly, we know that it's 4 carbons, so we know that it's going to be but. So the name is going to be butanoic acid. So the next step is to draw the fully displayed structural formulas. And the fully displayed structural formula would include having 4 carbons within the chain. Of course, one of them would be the functional group of the carboxylic acid. All right. And all the rest are going to have hydrogens, as we would have observed, we would have learned earlier today. All right. So, and there we have it. Our answer is complete. And we have 2 marks. All right. So let's look at the next question, 5. This is going to be the last one, I believe. Yes. Draw the following displayed structures of any 2 isomers of compound E. So we're looking at compound E. Give the name of each isomer you have drawn. So we're going to draw how many? So they said draw the fully displayed structure of 2 isomers, okay, of this compound, which is E. So let's make some space here so we can draw these 2. Now, in drawing this question, in doing this question, you are going to note something. They gave you a drawing of an isomer, and they ask you to draw 2 isomers. They are not asking you to redraw the same one. You need to know that you need to look at something different. So you would look at 2 different isomers. So note that it's an alkane, all right? And it being an alkane, we know that how we are going to do our isomers, we are going to now do branches. So I would take out one of these branches here. I select one and put it to the adjacent carbon, all right, which is this carbon here, all right. So I am going to have 1, 2, 3, 4, 5 carbons. So I'm going to draw a 5 carbon chain. 1, 2, 3, 4, 5. All right. And I am going to put my carbon on that chain, all right, which is the second carbon. It's right here. I said I'm going to put it on the adjacent one. And I have my carbon present there. All right. So this is my first isomer. Make sure you put in all your hydrogens. It's very important that you do. Okay. You can. All right. So you can't have a hydrocarbon without hydrogens. All right, so this was isomer number 1. We need to draw another isomer. So what's one of the same things that I said? One of the next step, if you remember from alkanes and the video with alkanes, we said that when you have done branching for alkanes, take that same branch and move it along the chain to see what are the possibilities you have with these branches. If you remember from that video, if you have not, take a look at that video. It's very important. All right. So I'm going to take this branch that I would have drawn. Let me use a different color. I would have taken this branch that I have drawn and move it to the adjacent carbon. Okay? So let's draw it and see how it's going to look. So I still have a carbon chain that has 5 carbons, 1, 2, 3, 4, and 5. And of course, I said that I'm going to move my CH3 group and put it right here. So I have my hydrogens bonded to it here, and I have another isomer. So very small and simple. You don't try to go and do anything complex and out of the way, okay? To just show here's what happening that I could draw more complex things. You don't need to do that. You just simply take the steps to making sure that you have the correct answer, all right? And making sure that you don't make any errors, all right? So you just need to always, when you are doing stuff like this, you should be able to look back and critique what you have done to see whether or not it is correct, all right? So I am confident that these answers are correct. I would like that you have that same stance when you do your exams, all right? So where this is concerned, we have come to the end of the program for today. Again, my name is Mr. Shea Thomas, and I have been your chemistry facilitator. All right, we want to thank those at the Division of Education for this program, the e-learn program. And students, I look forward to seeing you again for another session with chemistry with yours truly, Mr. Thomas. As I always say, keep sharp. Always keep sharp. Keep on top of your game. Where chemistry is not a subject that you're just going to just throw on. You have to always ensure that you are sharp. And in the end, I know and I'm confident that you will be successful. So, over and out, and have a wonderful evening.